Hello everyone, JCE Connect. So we'll continue with some more problems on unsymmetrical case of fillet weld. So here the problem given as a tie member of a truss consisting of an angle section ISA 65 by 65 by 6 mm of FE 410 grade is welded to an 8 mm gusset plate. Design a weld to transmit a factored load of 150 kilonewton. So in previous problem, the load was not given. There we have been calculated the design strength of member, and for that we have been calculated length of the welds. But in this case, a load is being given, and the section is mentioned here, and also the gusset plate is mentioned here. So this is the figure given, and the one is the longitudinal section of the section, uh, and another one is a cross section. So this one is a longitudinal section, this is a cross section. So here the the the, the figure clearly indicates that. So this is the section which has been this is the section which has been connecting to the gusset plate of 8 mm thickness, mentioned as 8 mm thickness plate, and the section mentioned as is a 65 by 65 by 6 mm, and the width of the section is 65 mm and the thickness is 6 mm, and the load carrying by this section is given, that is 150 kilonewton. And for this 150 kilonewton, this section is carrying 150 kilonewton. To resist this 150 kilonewton, what is the size of the weld and the length of the weld required here? That is the question asked here. This is the cross section. In this cross section, this indicates the gusset plate, and this is the angle section. For this angle section, here is the weld is done. Weld is been done. Here the weld is been done. Here mentioned the fillet weld, and this is the centroid of the section, that is CXX. This you have to take from the steel table. Next, here let L1 and L2 are the effective lengths. Here given L1 and L2 are the effective lengths of a weld at the top and bottom as shown in the figure. Here they are shown L1 and L2 are the length of the weld at top and bottom of the uh, section as shown in the figure. From the steel table, you have to refer the steel table and note down the properties of this section ISA 65 by 65 by 6 mm. You have to take the properties from the steel table and refers ISA 65 by 65 6 from the steel table, and there the properties are being given. Note down the area of the section, also the centroid of the section, that is CXX and EXX. From the CXX from the top, here they mentioned CXX, and the remaining will become the EXX. And also the given the load 150 kilonewton, then ultimate stress of the material is given Fu 410, then the thickness is 6 mm plate. Then the first step will be you have to take the minimum size of the weld. You have to refer the IS 800 2007 page table number 21. So there they have mentioned the minimum size of weld for different thicknesses of plates. So take that minimum size of the weld. Then the maximum size of the weld, as I explained earlier class, the maximum size of the weld is depending upon the uh, edge conditions for the square edge and for the round edge. Here the maximum size of the weld is been taken 6 minus 1.5. So 1.5, why it is to be deducting, everything is been given in a code book for the square edge. So you refer page number 78 and 79. There they are mentioned clearly why the 1.5 mm to be deducting from the thickness of the plate. So you will be getting the maximum size of the weld and a minimum size of weld. Then In between the minimum and maximum, you have to select one size of the weld that is been selected here is as a 4 mm. Then the effective throat thickness becomes uh, that is at effective throat thickness TE, that becomes 0.7 times of S, 0.7 times of S. Then you calculate the thickness. Here you will be getting thickness as 2.8 mm. Then the next will be the design strength of weld. This design strength of weld you need to calculate. Either you calculate for 1 millimeter length, or you keep length as it is and substitute remaining all things and get the design strength of weld. So here LW represents the length of the weld, T represents the effective throat thickness, Fu represents the ultimate stress in a plate material, then the root divided by root 3 into gamma mw. Gamma mw represents the partial safety factor for the weld. Here the partial safety factor has been taken as 1.25, and the effective length of the weld, that is LW, substitute all, you will be getting in terms of length because the length is the unknown here. Then this to be equating to the here this to equate to the load, that is equating the strength of weld to the factored load given. Then when you equate it, you will be getting the length of the weld required, total length of the weld required. Then this total length of the weld you need to apply on two sides of the section. Then to apply that one, then the CG of the angle section to be marked. This is the CG of the angle section is been marked in a figure. Just to refer the figure, this figure, the CG has been marked. Then to make the center of gravity of weld to coincide with the angle, so to here the to make the CG of the weld to coincide with the angle, this is the CG of the weld, that I'll show you. This is CG of the weld, this one. Then about this CG you take the moment, that is L1 into 18.1. This L1 into 18.1 is equal to L2 into 65 minus 18.1. So from this you will be getting L1 in terms of L2. I'll repeat. To make a CG of weld to coincide with that of angle, just take the moment of this length of weld and this length of weld about the CG. This is the CG. L1 into CXX and L2 into the remaining distance. So you will be getting length of the weld in terms of L2. So once you equate it, here LW equal to what? L1 plus L2. Then substitute the value of L1 in terms of L2, you will be getting in total length in terms of L2. Then you will be getting from this L2, that is 80 mm. Then you know the L1, then calculate L1, then hence provide L1 and L2, that is here L2 is 80 mm, L1 is 210 mm. So this is how to calculate length of the weld if you are applying on two sides for the given load, that is the design of weld.